All right, page 224 in your textbooks. You did numbers 20 through 36 in the homework section. We're going to look at those in just a moment. But first, I want to go ahead and review some things that we talked about last week. We've had a weekend to forget for those who go to our church. It was kind of a different weekend with homecoming and afternoon service and dinner on the grounds and games and activities and stuff. It was fun, but I'm going to be honest, it threw me off a little bit. It was weird. Anyway, my whole schedule, weird. Okay, so anyway, let's get ourselves back in the groove of things. We have two systems of measurement that we have studied. One system of measurement we here in America, we use. Nobody else really does, Liberia, okay, but most of the world doesn't use it because we're special like that, Sam. The U.S. customary measures, right? And the U.S. customary system of measurement has nice things that we like here in America, like feet and inches and pounds and ounces and cups and gallons and quarts and things like that. Now, the hard part about all those units is there's a lot of things you have to memorize. How many feet are in a mile? How many quarts are in the gallon? But how many fluid ounces are in the pint? And things like that, right? There's the other system that everybody else in the world uses. What's that system called, Kirsten?
Metric, customary, or something?
Just metric. Just the metric system. And the metric system is really based on three primary units. Your basic unit of mass, class, is the
meter.
Mass.
Gram.
Gram, right? Mass is how big something is, right? So the gram. When we talk about length, of course, that would be the meter. And when we talk about how much something can hold, how much is in Elaine's water bottle there, for instance, because we'd measure that in liters, right? And then if we wanted to have more than one or lots of something, then we could go to bigger units based on some key metric prefixes. But to help us remember our metric prefixes, class, we have a pseudo-historical pseudo-fact. And what is that pseudo-fact of history, class? King Henry died unexpectedly drinking chocolate milk. Now, the only problem is there's two D's in here. So for one of them, we make a little bit of an adjustment here. Bryson?
You put an A in the first one.
The first D gets a little A with it. And this will help us hopefully remember our 6 metric prefixes. Like Mr. Jesky, there's 7 letters. Right, but what does U stand for, class? Unit, right? It's just the basic gram, liter, or meter. But the other things represent our prefixes. Say them with me, class. Kilo, hecto, deca, deci, centi, milli. Again, kilo, hecto, deca, deci, centi, milli. Now, what does kilo actually mean, Michael? 1,000 of something. So a kilogram is 1,000 grams. A kilometer, is 1,000 meters. A kiloliter is 1,000 liters. What does hecto mean, Luciana? There's 100 of that gram or liter or whatever if you have a hecto whatever. Deca simply means, Jalen, 10 of that thing. But when you get past the unit, on this other side, deci means what then?
Tenth.
A tenth. So 1 of 10 parts of that thing. Centi gets even smaller, Kirsten. 100th. And then milli here would mean what, Griffin?
1,000.
1/1000th, right? So a millimeter is 1/1000th of that meter stick. Very, very small. And because all of these are powers of 10, then all we have to do is move the decimal. And so remember, we don't count from one letter to the next, but we count the number of points when we convert from one unit to the next. One thing, though, that's going to be helpful as we go through this, and we've reviewed this a few times now, is knowing the comparison between some of the metric units and some of the U.S. units. For instance, for us, if we were measuring something very, very light in the U.S., we would measure it in ounces. But if something's very, very light in the metric system, they would just use the gram. Which one's bigger, the gram or the ounce? Class?
Ounce.
The ounce. Okay, Michael, your moment. How many grams in an ounce?
28.35.
28.35. So class, which is bigger? Think for a moment. An ounce or a decagram? Class? Still the ounce, because what is a decagram? 10 grams, right? Deca means 10. Decagram is 10 grams. But Michael said it took 28.35 grams to make an ounce. So an ounce would be bigger than 10 grams, wouldn't it? In fact, it'd be a couple of decagrams, almost 3 decagrams. Which would be bigger, a hectogram or an ounce?
Hectogram.
The hectogram, because that's 100 grams, that's bigger than 28.35 grams, which is the ounce, right? So we should be able to make those adjustments. Which is bigger, a meter or a yard?
Meter.
A meter is going to be bigger. But they're pretty close, aren't they? So if you had 1,000 meters, we would call that class a 1,000 meters. Kilometer, right? Kilometer, kilometer. If you had 1,760 yards, class, we call that a mile. Which is those is going to be bigger, the mile or the kilometer?
Mile.
A mile, because it's 1,760 yards instead of 1,000 meters, right? So you have a lot more of them then. So the mile's bigger than the kilometer. Which one is really close to a liter? Which U.S. unit is really close to a liter, Ben?
Quart.
A quart, really, really close. Technically, which one's bigger, class?
Liter.
The liter, by just a tiny bit. Okay, then which one's bigger, a liter or a gallon?
Gallon.
Well, a gallon's 4 quarts, right? That's going to be way bigger than just a liter. Which is going to be bigger, a liter or a pint?
Liter.
Well, the liter's bigger because a quart is about the same size as a liter, and a quart is twice as big as a pint, so a liter's going to be about twice as big as a pint. Right? So do you see how to kind of think through the comparison between those? Which is bigger, a kilogram or a pound? Kilogram. In fact, it's a little more than 2 pounds. So we've got those different relationships, right, between those different units that we wanted to know. Page 224 to 225, let's take a look at the homework now that we've reviewed over these things. Good. Good. Looks like we did these ones. What about the top row, the 20 through 25?
I thought you
You
said
20. Get your homework assignment pad. I'll look at it in just a minute real quick. So 20 to 36.
I heard.
Well, that's why you want to get me to check it for you, make sure. Yeah, no, I
heard
said
20.
20 to 36. You want to make sure you copy it correctly in the future. All right, so let's take a look at these together. And remember, when you convert within the metric system, all you're doing is boinking from one unit to the next, and then you boink the decimal exactly the same way you'd boink everything else. So we're going to start with 34 meters. Now, we got to be careful, class. Where do I start my decimal on King Henry when he starts us with meters, class?
Unexpected.
The unit on the unexpectedly, right? Not at the M. That M stands for, class? Milli. This is not milli, it's meter. And we're going to centimeters. So I go boink, boink. Do not count 1, 2, 3. You count the number of boinks, class. How many boinks did we have? 2 boinks that way. Now in the 34 meters, where's the decimal, class?
At the end.
At the end. And so I'm going to take the decimal at the end, I'm going to boink twice, but the 2 boinks have to be filled in with zeros. So how many centimeters, class?
3,400.
3,400 centimeters. Number 21, we're going from milliliters to centiliters. What do we get when we boink just the one time, Elaine?
49.9.
49.9. Number 22, we convert from meters to kilometers. What are we going to get here, Corey? 0.000235 is correct. Number 23, we convert centigrams to decagrams, Griffin.
1.9.
Going from centi to deca. So I'm going to start here at C. I'm going to boink, boink, boink all the way to the deca. That's 3 boinks that way. They started us with 190, right? The decimal's back here. If I go 1, 2, 3, Griffin.
0.19.
0.190, or we don't need the 0 anymore, so just 0.19 decagrams is correct. Number 24, Kirsten.
5,500.
5,500 decaliters. Number 25, Sam.
10.25.
10.25 meters, because we're going to the unit, not to the M, but to the unit. Let's go back to Ben for number 26, 74.6 kiloliters. How many deciliters?
746,000.
Perfectly said as well. I'm glad you didn't throw an and in there. Great job. 746,000. Number 27, 29 hectograms. How many kilograms? Jalen, I know you weren't here, but let's take a look at it. We're starting at hecto, and we're going to kilos, so we only need to boink one place that way. What do we get? 2.9 kilograms. How about number 28, Bryson? Head off hand. I saw a water bottle down there on the floor. Head off hand was the thing I need to address there. 613 centiliters. How many hectoliters?
0.06.
.0613. How many got all 9 correct? You boinked correctly every time. Any questions on the boinking? Any boinking questions? All right, let's take a look at some word problems now. Number 29, largest watermelon ever, they say had a mass of 118 kilograms. So how many grams was the watermelon, and then how many decagrams was said watermelon? And Luciana, what did you get for the first answer?
118,000 grams.
118,000 grams, and then for your next answer?
11,800 decagrams.
11,800 decagrams is correct. Very good. Number 30. Average depth of the Red Sea is 491 meters. What would that depth be in kilometers, Michael?
0.491 kilometers.
0.491 kilometers is correct. Number 31. Sugars packaged in cartons containing 2,000 sugar packets. Each packet has a mass of 2.8 grams. What is the mass of a carton of sugar in kilograms? Well, first of all, class, if every packet's 2.8 grams and there's 2,000 packets, what do you suppose we should do? Multiply. 2.8 times 2,000, right? Now, I'm going to hang the 3 zeros here. 2.8 times 2 is going to give us what, anybody?
16.
Well, 16 carries, so we get 56. We're going to put the 3 zeros back and now put in 1 decimal place. So we get
5,600.
5,600. That's how many what? That's how many
Grams.
grams of sugar there are. 5,600 grams. But it wanted to know in kilograms. Class, where do I start?
Okay. Oh, wait, no.
At the unit. I have grams. I have unit. I want kilograms. So we boink
3 times.
3 places that way. And if we do, class, we get
5.6.
5.6 kilograms. Now, the shortcut would have been this. How many grams does it take to make a kilogram? What does kilo mean?
1,000.
1,000. So if there's 2,000 packets, the 1,000's already there for you. You could just multiply by 2. Realizing the 1,000 converts it to kilograms, and the shortcut would have been that to get to 5.6 kilograms. But this is the more conventional approach. Number 32, Howard's swimming pool, 130 centimeters deep. How deep was it in hectometers? What did we get for this one, Ben?
0.013.
0.013 hectometers is correct. Number 33, this has nothing to do with the metric system, but you know, whatever. When golfing, how many golf? Any golf in here?
Oh, no.
How many mini golf? All right, here we go. All right. A lot less effort, right? And when golfing, Rochelle's ball landed on the fairway 10 times and landed in the rough 8 times. Okay, so the fairway is where you want the ball to go. It's been nicely mowed and manicured for you. And then the rough is where they mowed for a while. And it's going to be hard to get the ball out of there because it's like hiding down in the grass. Good luck finding it. Anyway, she found it. 8 times in the rough, 10 times on the fairway. What's the ratio of times the ball landed on the fairway to times it landed in the rough? Elaine?
5 to 9.
Well, 10 times fairway, 8 times rough should just be 10 to 8, which reduces to
5 to 4.
5 to 4. Then it says letter B, what's the ratio of times the ball landed in the rough to total number of times the ball was hit? Well, first of all, how many total times was the ball hit?
18.
Well, I was asking Elaine, but yes, 18 is correct. And how many times in the rough, Elaine?
10 or 18.
Eight.
Okay, I'm confused. All right, let's see.
In the rough, how many times?
10.
No, that was the fairway.
8.
See, yeah, eight times in the rough. There we go. It's a Monday. 8 times in the rough, and then total times hit we said was
18.
So the ratio is 8 to 18, or you reduce it to get
4 to 9.
4 to 9. Our answer for letter B. Questions on number 33. All right. Number 34. Edwin mowed 11 lawns using a push mower 8 times and a riding mower 3 times. So 11 lawns. 8 times push mower, 3 times riding mower. So apparently 8 times the yard was too small to justify cranking up the riding lawnmower. Some of you'd be like, I don't care if the yard's the size of this classroom. If I've got a choice, I'm using the riding lawnmower. Okay, but maybe his dad didn't want him using the riding lawnmower that many times. Anyway, what's the ratio of lawns mowed with a push mower to lawns mowed with the riding mower, Corey?
8 to 3.
What about the ratio of lawns mowed using a push mower to total lawns mowed, Corey?
8 to 11.
8 to 11. No reducing that time because the numbers were all prime to each other. No common factors. Number 35. Local bakery sells 14 cupcakes for every 2 cakes. What's the ratio of cupcakes to cakes, Griffin?
14 to 2.
14 to 2, which reduces
7 to 1.
7 to 1. Then what's the ratio of cupcakes to total items sold?
7 to 8.
14 to 16, which reduces to 7 to 8. Very good. And number 36, Jared marked on his chore list that he did the dishes 5 times and cooked dinner 15 times. Anyone in here cook dinner for your family at this point? Have you ever cooked? Okay, so several of you. Good, that's good. Several of you actually do some cooking then. That's good. My thing was pancakes when I was this age. I could make pancakes. I could mix the batter up properly. I could flip pancakes. And then gradually progress to things like sausage and bacon and scrambled eggs and fried eggs and hash browns. I got to just about anything breakfast. Really good. Outside breakfast, you know, was a little dicey, but I could cook on my own, which was good because when I graduated college, I was a bachelor for a year before I got married, and so it was good that I could cook because otherwise I would have starved, you know, or gotten fat off of Little Caesars Pizza, which was right down the street. So anyway, Jared cooks and does dishes sometimes, helping out the family. That's good. Carry your weight, right? Contribute to the household. And what's the ratio of dishes done to dinners cooked? Kirsten?
5 to 15.
Which reduces to?
1 to 2. Or 1/2.
5 to 15.
1 to 3.
1 to 3, there we go. Okay, and what's the ratio of dishes done to total number of chores done?
5 to 20.
Which reduces to?
1 to 4.
1 to 4, there we go. I feel like if that's all the chores he had though, something's missing. Like take out the trash maybe, vacuum maybe, sweep maybe, wash the car maybe, mow the lawn maybe. Anyway, but I digress. I shouldn't be picking. Maybe it's a really big family, right? And so there's other people who have to carry their weight and do those chores. I don't know. Anyway, how many of your family has like designated chores? Like this is your chore, this is their chore? How many is just like, it's whatever mom says at the moment, that's my chore, dad says at the moment, that's my chore? Yeah, that was kind of more or less how our role was. So as I got older, you know, I got more and more of the outdoor work dumped on me. So my dad's like, okay, you're doing all the stuff outdoors, you're cleaning gutters, you're cleaning soffits, you're washing car, you're pressure washing, you're mowing, you're edging, you're, you know, transplanting bushes. Okay, we can make the girls do most of the dishes and cooking. That he didn't want me to cook because my dad likes to eat good food. He didn't want me to cook. He never ate my pancakes.
Aww.
He doesn't really like pancakes. Anyway, or maybe he just said that because he didn't want to eat mine. I don't know, Dad. What is it? I don't know if you're watching YouTube. All right, anyway. Questions on this? Yes, sir.
Good question. Do you know how to fix French toast?
I do know how to make French toast. Yes. Yeah.
Can you make us some?
No. All right. Are you kidding me? You know how much French toast that would take? I mean, Sam alone would. Just picking on Sam. He's not fat, in case you're wondering, and you're like, how big is this kid? He's not fat. I'm just picking on him because he's in the front, okay? It's either him or Jalen, and decided to be safer to pick on Sam than Jalen. Anyway. Questions on the word problems. Questions on the metric system. Questions on the metric system. Are we good to go with boinking the decimal from one letter to the next? Let's take a quiz over boinking the decimal. Hey, you said you were good. This should be an easy 100, right?
Yeah.
Clear your desk, except for a clean sheet of paper, and a pencil. Everything else away. I will say this, don't make a careless mistake on this quiz. Like, this should be an easy A. Don't try to do something in your head that you maybe should show on paper and then missing it and getting a 90 or an 80 or something and being like kicking yourself because you didn't get 100. Okay, so just be careful with the quiz. All right, desk clear except for a clean sheet of paper and a pencil. Everything else away. This is quiz 22 for those watching on YouTube. Make sure you're taking the correct quiz. Quiz 22. Pass that rest. There you go. All right. Take one, pass the rest back. Oh, and you can just leave the extra on the desk behind you there, Michael. All right, let's take a look at the quiz together. By the way, first and last name, of course, in the name spot. First and last name in the name spot. Today's date in the date spot. Today is 10/23/23. 10/23/23. It is Mole Day. You have to ask Miss Morse about that one. It is Mole Day today. She can explain to you. No, we are not celebrating little creatures that eat worms and bugs from your yard. Mole trails. That's not that kind of mole. Different kind of mole. Anyway, let's take a look at the quiz very quickly together. Numbers 1 through 4, you're just telling me which of those units is bigger. Numbers 5 through 10, you're converting. I would highly suggest writing out a series of letters off to the side and doing some pencil motions as you do these. All right, you may begin. So you're using your your blank page as a cover sheet. Use the blank page as a cover sheet.
What is it?
Just a couple more minutes to be finishing up. you're watching on YouTube and you need just a little bit more time, that is your choice. You can pause the video, but we're done in here. We'll take a look at those quizzes tomorrow. For now, if you would open up your textbooks to page 225, and we're going to talk about some measures today that are not U.S. units or metric units, they're both. There's one thing we can all agree on in the world, and that's time. Time. Because time isn't necessarily something that has been contrived by one group of people or another. It's something that was more or less really established by God, wasn't it? Many of the things that we use as time are universal because they're things that God ordained in one way or another. For instance, when we measure years, what is a year? Ben?
365 days.
Well, we say it's 365 days, yeah, but Willie, like, before people counted up how many days it was, like, how did people decide what a year would be? Bryson?
Or like, how many, like the time that's supposed to go down.
Sam?
Like, is it how, like, you know, the old clock, how many times that would go around?
The clock goes around?
I don't know.
You know, like,
It has something to do with, shall we say, planetary motion, Kirsten?
Like the sun setting in the east or something like that.
Ben wants redemption so badly.
That every time the Earth
Oh.
has a full rotation around the sun.
There we go. Revolution is the term for it, but a full revolution around the sun, right? From one point around the sun back around to the same point again. That's how people decided what a year would be. Now, technically, what we call a solar year isn't exactly 365 days. It's about 365 and a quarter days. So, what do we do about that? Well, quarter days would be really awkward for us, wouldn't it? Like you show up to school for like, no, we can't be doing this. So what do? Every 4 years, class, they take those 4 quarter days and they make a leap year out of it, right? So we understand this, that a conventional year, class, has how many days?
365.
Conventional year, 365 days. But because it's not exactly 365, every 4 years we have a leap year, which is 366. Now, technically, it's not exactly 365 and a quarter days. It's, if you look in your textbooks, page 225, you see where it says solar year, how long it takes the Earth to revolve around the sun. It says a solar year takes 365 days, 6 hours, 9 minutes, and 9.54 seconds.
What?
Now, how many hours are in a day, class?
24.
We already know that there's 24 hours in a day. 6 hours would be a quarter day, correct? Is it 365 days, 6 hours? There's those nagging little extra 9 minutes and 9.54 seconds, right? How do we adjust for the fact that it's not quite that quarter perfectly? Well, every 100 years, we skip a leap year. Did you realize that? You haven't been alive to experience that. So here's the way we work leap years. You know that a leap year is every 4 years, correct?
Yes.
So for instance, 2004, 2008, class.
2012.
This is about the time most of you were born, right? Somewhere around 2012-ish, maybe a little before. And then 2016, 2020. When's the next leap year? 2024, this coming February. We get the extra leap day, don't we? And we could go on and on and on like this. But eventually, class, we're going to get up to 2080. Well, that's a leap year because it's divisible by 4, isn't it? 2088, 2092, 2096. Now, 4 years after 2096, class, is what year? 2100. But on 2100, they're not going to have a leap year that year. We might not be alive still. I don't know, right? Because y'all will be 90. I'm going to be dead by then. I think the Lord probably raptures us home by then, just seeing the way things are going in the world. But I don't know that. But if the Lord tarries, 2100 will not be a leap year. Even though it's 4 years after 2096. And even though it's 4 years before 2104. Which is just weird to think that far in the future. But anyway, even though it's 4 years between those, they're going to skip the leap year. They also skipped the leap year on 1900. They skipped the leap year on 1800. They skipped the leap year on 1700. But 1600 was a leap year. And the year 2000 was a leap year. So here's what they decided to do. Every 100 years they'd skip it, but if the year was divisible by 400, they would make a leap year. You remember our divisibility rules, right?
Yes.
Numbers are divisible by 4 if the last two digits are divisible by 4 or if there's a double zero. Well, what they decided for leap years is double zero years would not be leap years unless it was divisible by 400. And that allows us to keep track of solar years, keeping track of those nagging 9 minutes and 9.54 seconds with really good accuracy. You'll study, if you haven't already, in history. Have you gotten to the Roman Empire yet?
Yeah.
And the popes and stuff?
Yeah.
Okay, Pope Gregory, the Gregorian calendar. Okay, the Gregorian calendar was one that was Julius Caesar. You've studied Julius Caesar? The Julian calendar. There was a couple different calendars they came up with, and the Gregorian calendar took into account all these little details to try to keep things lined up really perfectly with the solar years. So anyway, that's how the leap years work. Every 4 years is a leap year, unless, class, it ends in double zero. Then it can be a leap year if the whole thing is divisible by 400. So little nagging details there. By the way, there's another kind of year that we're going to talk about later this year when we talk about money. It's called a commercial year. Anything to do with money, the commercial year doesn't have 365 days. Because 365 is a really awkward number to use. Instead, they use 360 days. Because you can divide 360 by just about anything, it feels like. And that allows you to figure interest on loans and things like that with a lot more accuracy. So the commercial year is 360 days. Conventional year, though, class, what we need to know is 365. And every 4 years, for the most part, class, we have a leap year that has 366 days. What about a month? How did God, so to speak, I mean, if God set up the year by the earth going around the sun, okay, that's a year. How did God set up the month?
Phases of the moon.
The phases of the moon. A month is our word for a moonth. From a new moon to another new moon is roughly 30 days. And that's where they got roughly the month, so to speak, right? So the months are based off the moon. The year is based off the sun. Put them all together. There's our calendar. How many months in a year, class? 12. 12 months in the year. And of course, we decide, if you read in the Bible and it talks about the first month, it's not necessarily January. We call it January. They have other names for it. And of course, the Jews base everything off of Passover. That began their first day of their year. We have it on what we call January 1st. Chinese New Year's a different day. But whatever. The month, still every culture has 12 months in a year. What about a week? How did God set up a week? 7 days of creation, right? Where God rested on the seventh day. And by the way, there was, I don't know if you've talked about this yet, you haven't gotten to the French Revolution yet, that's coming. But when the French were seeking to overthrow their government, they knew the only way they could overthrow the government and have total anarchy is if they got rid of God. And so they tried to get rid of God. And some really smart people realized a week is biblical. So we got to get rid of this whole week nonsense. 7 days, that's based on Bible. So we said, well, what we're going to do, we like the number 10, right? Kilo, deca, hecto, deca, deci, centi, milli. We like 10. Let's do 10 days in the week. People couldn't handle it. Horses couldn't handle it. The animals couldn't handle working 9 days and taking one off. Our bodies were designed by God to handle 6 days and a day of rest. We need that day of rest every 7 days. God built our bodies for that. And they ran into problems when they tried to go to the atheist week, the 10-day week. And so the 7-day week, that's based on creation. What about a day? What's a day?
24 hours.
Well, we say it's 24 hours, but what is a day?
When the sun goes down.
One rotation of the
One
Earth.
spin of the earth, right? That's why, by the way, the sun rises, right, and the sun sets. It's not really the sun moving, it's us moving, right? As we spin, the sun goes up, the sun goes down. The next time the sun rises another day, it's 24 hours, right? So we understand 24 hours in a day. That's the spin that God gave to our earth. We know, of course, there's how many hours in the day, class? 24 hours in the day. How many minutes in an hour? 60. That goes back, by the way, the whole idea of the 60, that kind of thing, goes back to the Sumerians, who realized 60 was a great number to divide things by, because 60 is divisible by a whole lot of things, and then each minute can be divided into 60 parts, called Second, 60 seconds in the minute. Okay, so all those different things there. And then if we were to have lots of years, we can put groups of years together by names as well. We know, for instance, if there are 10 years, class, we call it a
Century.
10 years, decade. Remember, deca means 10, so a decade. You were thinking of 100 years being a century, right? A century would be 100 years. By the way, which century are we in?
2000.
We're in the 2000s, right? Which number century is that? This is always confusing for kids. It's the 21st century. Think about it this way. From 0 to 99 was the first century. From 100 to 199 was the second century. So if it starts with 1, it's the second century. So fast forward, when did Christopher Columbus discover the New World? 1492. So that would be the 1400 to 1492. But which century was that? It was the 15th century. So when you hear the 18th century, what years were those? If people talk about the 1700s, right? When the French and Indian War was being fought, when the United States was vying for independence from England and won its independence, that all took place during the 18th century or the 1700s. So since we're in the 2000s, this is the 21st century. The 1900s, that's when I was born and spent my growing up years, was in the 1900s. That was the 20th century. I'm not that old. Stop laughing, Bryson. Remember, I still got you for PE later. Okay, then question.
What's 1,000 years again?
Well, let's talk about that. What if we had 1,000 years, class? What do we call that? Millennium. Okay, which millennium are we in? The third. We just started the third millennium about 23 years ago, right? Because the first millennium is 0 to 999. From 1,000 to 1,999 was second, and now we're in the 2000s, so we're up to the third millennium. There's one other thing the Bible uses quite a bit. We don't use it quite as often anymore, but if you had 20 years, we call that a score. In general, score could be 20 of anything, but we normally use it in the sense of time to mean 20 years. You see all of those measures there on page 225. Let's recite them together as a class. 1 minute equals 60 seconds. 1 hour equals 60 minutes. 1 day equals 24 hours. 1 week equals 7 days. 1 year equals about 52 weeks. Pause there, put a star next to that one. That's a number we don't use very often, right? We're all used to hearing, we are open 24 hours a day, 7 days a week, 365 days a year, right? So 24/7, 365, we're used to hearing those numbers. 52 weeks we're not used to hearing. What is 7 times 52? Fast math people, help me.
364.
364, good, Bryson. Almost 365. Have you ever noticed, by the way, that the start of school seems to be a day off every year? It's another day off. That's because there's one extra day on top of the 52 weeks. But anyway, so 52 weeks, and notice they have a squiggly equal sign, approximately equal to 52 weeks. Let's keep going. 1 year equals 365 days. 1 leap year equals 366 days. 1 year equals 12 months. 1 decade equals 10 years. 1 score of years equals 20 years. 1 century equals 100 years. 1 millennium equals 1,000 years. And again, notice the wording, a score of years, because technically a score could be 20 of anything. Turn over to page 226. Turn over to page 226. I want you to do numbers 1 through 9 at the bottom of the page. Numbers 1 through 9 at the bottom of page 226. Filling in those blanks very quickly. These are things most students struggle with a whole lot less than cups and pints and fluid ounces and gallons and quarts, right? Because these are things we use every day. These should be a lot easier numbers to remember for us. By the way, you see up there the yellow blurby thing about leap year. They'll talk a little bit more, that's where the book kind of goes into the leap year information. If you kind of wanted to read that over again, you're like, I heard what you said, but I didn't quite get it. Can you go over it more slowly? Read that over later. Goes over the leap year again. All right, number 1, Michael, 1 year equals?
12 months.
Number 2, Kirsten, a week equals?
7 days.
7 days. Number 3, a century equals, Griffin?
100 years.
100 years. Number 4, a year equals, Corey?
365.
365 days. A year equals about, or how many weeks? They should have a squiggly equal sign there, Ben.
52.
52. Number 6, a leap year. How many days, Luciana?
366.
366. Number 7, an hour. How many minutes, Bryson?
60.
60 minutes. Number 8, a day. How many hours, Elaine?
24.
And a millennium. How many years, Sam? 1,000 years. Somebody got all 9 of those correct. Certainly should have. Look across the page. Numbers 10, 11, and 12 now. Write those units, number them in order from least to greatest. So in each column, find the smallest one, put a 1. Find the biggest one, that's going to be your 5. So 1 through 5 getting bigger as they go. Take a moment to do numbers 10 through 12. Going smallest to largest with your numbering. All right, number 10, Jalen. Which one did you put? Go ahead and read them actually in your order 1 through 5. Tell me what you had.
Second, minute, day, week, month.
Good. Second, minute, day, week, month. How about number 11? What did you put, Bryson?
Okay. 3, 2, 4, 5, 1.
Okay, 3, 2, 4, 5, 1. So read them in order from smallest to greatest.
Hour, day, year, century, millennium.
Good. Hour, day, year, century, millennium. And then number 12, what did you put? Luciana?
Second year, leap year, decade, and score years.
Good. Second year, leap year, decade, and score of years. Turn over the or drop down to the bottom of the page, middle of the page, I guess technically. Number 25, and let's read about Chloe and her appendectomy. And number 25, read it for us, Michael.
Chloe had an emergency appendectomy. She was in the hospital from Monday at 8 p.m. to Thursday at 8:15 p.m. How many hours was she in the hospital?
All right, what is an appendectomy anyway? Who knows what that is? Elaine?
Like you take their appendix out.
Yeah, the appendix gets removed. So you're in biology, or you're in Earth and Space Science. Next year in life science, you'll study more, though you might have learned this in elementary. How many know what the appendix is? It's a part of your digestive tract. Some people have speculated that it's not particularly needful. Apparently, there are some important digestive bacteria and digestive enzymes that are produced there, but you can live without it. So if it gets inflamed and is causing pain, the doctor's just like, cut it out, and it goes. Bye-bye, no more appendix. So anyway, Chloe has not had an appendectomy at this point, but anyway, hopefully she doesn't have to. It's funny, she was actually asking me, what's an appendix? What's it for? Like, I don't know, a couple of weeks ago. So this is really random. There we go, Chloe. That's my daughter, by the way, for those who are wondering, like, who is Chloe? She's my firstborn. Anyway, she's in the hospital for a lot of hours. At your seats, figure out how many hours is she in the hospital. Monday at 8 p.m. she goes in. She gets out Thursday at 8:15 p.m. How many hours is she there? Take a moment. Now, if you're going, let's see, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, don't do that. Don't do that. There's a much easier, faster way. Michael, what did you get for your answer?
You want me to be exact, or do you?
Yes.
96 1/4 hours.
Oh, he fell into a trap. It is not 96 1/4 hours. Kirsten.
12? No.
Oh, dear. Oh, dear. You fell into a totally different trap. Though I wouldn't say it was a trap they laid for you, Sam.
Is it 32 to 15 minutes?
Well, you're right about the 15 minutes, but since they said hours, by the way, here's a quick note, right? 1 hour is 60 minutes, right? So 15 minutes is 1/4. of that, right? Another fourth here, another fourth here, and the final fourth here. So it could be good to know that 15 minutes is 1/4 hour, just for future reference. Michael's trying to amend his answer there.
Never mind.
Luciana.
96 hours and 15 minutes.
Okay. All right, so let's go here, class. Monday, 8 p.m., right? The fast way to do this is count full days, right? So by the time you get to Tuesday at 8 p.m., class, that's how many hours?
24 hours.
That's 24. And you go to Wednesday at 8 p.m., class, that's another 24 hours. Then you go to Thursday at 8 p.m., and that's another 24 hours. But she got out at 8:15 p.m. So we got 24, 24, 24, class. 24 times 3 is 72. And then we've got that extra 15 minutes. So we'd say 72.25 hours. Does that make sense? So Michael, I think you said Monday, Tuesday, Wednesday, Thursdays, 4 days, but Monday to Tuesday is 1, Tuesday to Wednesday is 1, Wednesday to Thursday is a
That's
third.
exactly
How
what I
much would
did.
that bill be?
Depends on the or the health insurance plan you have. We're going to talk about health insurance next semester when we talk about finance. We're going to talk about a lot of the ins and outs of how math applies to everyday life and finance. So yes, that's coming later. But anyway, not for right now. All right. How many had 72.25? I called on all the wrong people. All right, number 26. Read that one for us if you would, Kirsten.
Oh. Old Faithful, the famous geyser in Yellowstone National Park, erupts once every 94 minutes. How many times per day does Old Faithful erupt?
Ooh, all right. At your seats. Take a moment. You stuck around all day to just sit there and watch Old Faithful get soaked every 94. You sit back further so you didn't get all wet. But you sit back. How many times would you watch Old Faithful erupt? Every 94 minutes. Spraying water and steam up out of the earth. Question or answer?
Question.
Yes.
Wouldn't it hurt if the water got on you since it's not
If it's scalding hot, then yes, that would be burned. I'm pretty sure they have a fence, right? I've never been to Yellowstone. If you're wanting to, by the way, send contributions to help me and my family get to Yellowstone to see these great things, I do accept donations. So, anyway, putting that out there. How many times a day does Old Faithful erupt? All right, Kirsten, you got it? You don't got it. You're sitting back there like, no, not me. Well, what would we need to do? Every 94 minutes, right? We need to figure out how many minutes there are in a day, don't we?
Yeah.
Well, how many hours are in a day, Kirsten?
24.
24 hours, and how many minutes in every hour?
60.
So if we hang the 0, how many minutes in a day? So we would multiply 6 times 4.
6 times 4. Oh, my goodness. 6 times 4 is. Oh!
Helper class.
24.
24. We're going to carry
Oh
this.
my
She's like, I do that. 6 times 2 plus 2?
6 times 2 plus 2, 14.
14. Okay, so this is how many minutes there are in a day. And how many minutes does Old Faithful erupt?
What? How many times?
How many minutes does Old Faithful erupt according to the word problem?
94.
Every 94 minutes. So if we simply divide this by 94, that'll tell us how many eruptions we're going to get. And so when we do this, let's see, 9 goes into 14 class.
Once.
Just once, right? Obviously 1 times 94 class. 94. So let's subtract the 94. What do we get? 0 and 5. So 50. We'll bring down this. How many times would 9 go into 50 class? 5 times. Okay, 5 times 4. 20. Carry the 2. 5 times 9 plus 2. 47. We subtract, we get just 30. So about 15 times. Now, what that means is every couple of days it's going to erupt a 16th time. It'll erupt early and then late, but basically 15 times. How many had 15 eruptions a day that you can count on? Ooh, okay, does it make sense now how to have solved a problem like that? All right, homework for this evening is to do page 227 to 228. Page 227 to 228. Do the review, 27 to 37. Page 227 to 228. Do the review, 27 to 37. Page 227 to 228. Review, 27 to 37. All right, we'll take a look at all that in our lesson tomorrow. Let's take a look at the quizzes you took today. Have a wonderful rest of your day. And when the bell rings, you are dismissed.
We did it!